Hi all, my name is Ganesh Rajendra Jadhav. I am explain project number 2, model number 2, end course capstone project. First, I have explained the uh, problem number 1, power of 2. The in this uh, mm, in example, first I will explain the introduction. This is a problem type is a bit manipulation, and goal is a check whether a number is a power of 2, and like a focus is a efficient solution using bitwise operators, and complexity optimization in important because checking power repeatedly should be fast. Problem understanding like input like integer n, and then output like a true and false value. In burst force approach in this program, so keeping dividing by 2 until number become a 1. So that's related, and if any reminder appears, return to fails. Time complexity is big of O log n, and optimize approach like key observation power of 2 number have only two only one set bit. In data structure use, no extra data structure are required in this problem. Only bitwise operation is required. And complexity analysis in this program is time is big of O1, and space is the same big of O1. Uh, in this program, challenges and learning is understanding the bit manipulation patterns, learned how to power of the 2 contains exactly one set bit. This is a in this program we have had correction here. We are in a return to n uh, greater than 0. This existing solution is a or use, but here we have used and. So this is a correction here. Second is a problem number 10, search ranges. So in this model, we have used like a introduction, like introduction wise is a problem statement. Problem type is a array searching first and last occurrences of the targets. Problem type, problem understanding, and input and output like that type is input is provide the array, and output provide the like in input, for example, like number is equal to in array 5 7 7 8 8 10, in target like equal to 8. So output like 3 and 4. So that's it. In this problem is a burst force approach like logic like a traverse entire array and store the every occurrences. The optimized approach is a current solution is a forward traversal and backward traversals. So forward traversals is a first occurrences, and first second is a backward traversals. And in find last occurrences is a it is a stop immediately once match the found, and no need to store all indexes. In this code like a data structure use like array types, and complexity wise time is a big of O(n), and space is a big of O(1), and challenges is in this uh, problem like first finding first and last occurrences separately, and learn how to binary search can further optimize. So use the forward loop find first occurrences, and backward loop find last occurrences. Then if target not found, return to -1 -1. This. And next is problem number 11, find peak element. In this problem is an introduction, like problem type is a binary search, and find an element greater than neighbors. Problem understanding, like input provide the array in 1 2 3 1, and output type is a 2. So first force approach, like logic, like check every element, compare with the neighbors. Complexity is a time is a big of O n. Optimize approach, like a binary search, and otherwise it complexity wise time is a big of O log n, and space wise big of O 1. Data structure use is a variables when only in this problem, no extra data structure use. And challenges and learning here, so understanding binary search and unsorted data, and learn pick like uh, in unsorted data, and learn pick always exist. And next is a problem number 16 is a missing number. So in this traditional approach, and not to is second is a optimized approach. uh, Two types of approach here. So in introduction, like problem type is array plus hashing, and cyclic sort. Find smallest missing positive numbers here, and problem like input provided, for example 3 4 minus ones, and 1. So output like values is a 2. And first force, like logic, like store all element here, and optimize approach, like a cyclic sort here. So in like logic, like place every value at a correct positions. For example, 1 2 3, 1 is in index 0, 2 index 1s, and index 3 is index 2. And complexity wise, big of time complexity is a big of O n, and space is a big of O 1. Data structure is a statistical set, and time complexity is a hash set, and cyclic sort. Uh, it's has set like a big time and space same. It's big up O n and big up O n in space. So cyclic sort, like big up O n and big up O 1. Challenges and learning is understanding here. So understanding index mapping, learn cyclic sort pattern, missing number, and next is a problem number 21. So in problem number 21 is a max bitwise. In this worst cases and best cases example here, I have implemented both, like worst case and best case. First add worst case function, like means problem type is a bit manipulation, find maximum bit wise result here. Problem understanding, in input like 5 7 10, and output maximum bitwise value. Bitwise burst force approach, like logic, like check every PS, array A and array J, array I and J. So other and next is the optimize approach or operations here. uh, and So single retrievals, and complexity is a big of O n, and space is a big of O 1. uh, Data structure use is a variable only, and uh, In complexity analysis, like a nested loop and single loop. Uh, in nested loop, like time and space complexity wise, time is a big up O n square and space is a big up 1 O 1. A single is a single loop like a big up O n and space complexity big up 1 O 1. And challenges learning in the understanding bitwise operators and learn to how to bitwise operation optimization can reduce the time complexity significantly. And this I understood the problem constraints discussion, like a first simple burst force solution, and after identify limitations I optimize using appropriate technique in binary search, hashing, bitwise manipulation, cyclic sort in this all program. Thanks all from my side.